Welcome to AI Frontiers, the podcast exploring the cutting-edge world of artificial intelligence and robotics. Today's episode, titled Robotics Revolution, Adaptive Machines in Action, synthesizes 24 papers from July 22, 2025. This deep dive examines innovations from AI-driven control to bio-inspired designs, all drawn from a single day's publications on the arXiv preprint server. This presentation overviews a surge of 24 robotics papers from one explosive day on the arXiv preprint server. Themes such as adaptive learning and ethical interactions are explored, highlighting breakthroughs that could transform daily life. From space debris cleanup to home assistance, the evolution of robots into smart, human-like partners is examined. Key findings, methods, standout papers, and future visions are covered. Suitable for experts and curious minds alike, the journey reveals how robotics amplifies human potential. Computer science. Robotics merges AI, engineering, and control systems to design machines that sense, decide, and act in the physical world. Key focuses include enabling robots to navigate environments from warehouses to surgeries using sensors and machine learning. Significance lies in addressing global challenges like disaster response, sustainable farming, and space exploration. These 24 papers showcase rapid advances in adaptive, ethical, and efficient robotic systems. Overall, the field centers on creating safe, intelligent machines that collaborate with humans. One dominant research theme is adaptive learning and control, a key element in robotics evolution. Reinforcement learning, or RL, teaches robots through trial and error rewards, enabling adaptive behaviors without predefined rules. For example, Jacob et al. Apply RL for manipulating deformable clusters, like tangled branches, using whole arm policies. This approach is seen in multi-agent setups for underwater coral sampling, achieving zero-shot sim-to-real transfer. The theme fosters teamwork and improvisation, similar to coaching robots for dynamic environments. Evidence from the papers indicates that RL reduces training costs and enhances efficiency in real-world tasks. Another prominent theme involves bio-inspired and efficient designs, drawing from nature for optimization. Bio-inspired designs mimic elements like human arm mechanics to optimize energy use in robots. Topology optimization, a method that iteratively removes material for lighter structures, reduces weight by 19% in legged robots. Papers demonstrate energy savings up to 48% in tasks like construction by trading kinetic and potential energy. This theme enhances sustainability, ideal for battery-limited applications in harsh environments. It is supported by studies on drone formations inspired by animal flocks for efficient navigation. A third theme focuses on advanced perception and interaction, enabling robust navigation and ethics. Advanced perception fuses sensors like LiDAR and cameras for precise calibration, reducing errors by 2.3 times. Emphasis is placed on human-robot interaction, particularly ethics, such as privacy recognition in social scenarios. Kandan et al. Use adaptive pose estimation for space debris, handling noise with Kalman filters. This theme bridges perception to ethical actions, fostering trust in embodied robots. Evidence includes sim-to-real transfers for grasping and navigation in challenging settings. Continuing with the theme of advanced perception and interaction, building human-centric robotics is emphasized. Lan et al. Ground vision language models with self-generated memories, jumping task success to 80%. Techniques like equivariant RL incorporate symmetries for 20 to 30% better grasping efficiency. Overlaps with ethics include benchmarking large language models for privacy, boosting agreement with human preferences. Key aspects involve making robots intuitive and respectful, such as expressive animatronic faces for emotions. These advances ensure safe, adaptive interactions in homes, space, and beyond. Several transformative insights emerge as key findings from the papers. Biomimicry slashes energy use by 48% in construction tasks, as shown by Jacob et al. Zero-shot sim-to-reel transfers enable flawless underwater sampling, cutting costs dramatically. Adaptive pose estimation reduces errors by 65% for space debris removal, according to Candon et al. Self-generated memories boost robot task success from 22% to 80%. Per Lan et al. Ethical prompting in large language models aligns privacy recognition closer to human standards. Common methodologies are synthesized across the papers. Reinforcement learning maximizes rewards for adaptive policies, strong in uncertainty but data-intensive. Topology optimization refines structures for efficiency, computationally heavy yet effective for weight reduction. Attention mechanisms and networks focus on key data, capturing patterns but demanding high compute. Unscented Kalman filters fuse sensors probabilistically for state estimation. Robust in nonlinear scenarios, retrieval-augmented generation leverages memories for planning, boosting adaptation with potential biases. The first selected research paper is Deformable Cluster Manipulation via Whole Arm Policy Learning by Jacob et al. 2025. It is selected for its novelty in model-free reinforcement learning for soft material handling, impacting safety in utility tasks. The objective is to enable whole arm manipulation of tangled deformables like branches without predefined models. Methods fuse point clouds and haptics with distributional RL for zero-shot sim-to-reel transfer. Findings show 25 to 40% better performance than baselines, with emerging creative strategies in physical tests. Significance lies in advancing generalist robots for cluttered environments, reducing human risks. The second selected research paper is Experience is the Best Teacher, Grounding Vision Language Models for Robotics Through Self-Generated Memory by Lan et al. 2025. It is chosen for its innovative grounding of vision language models in embodied agents, representing human-like learning directions. The objective is to bridge domain gaps for vision language models to enable autonomous planning and adaptation in physical tasks. Methods include self-reflection loops and retrieval-augmented generation with sensor verification. Findings boost success from 36% to 84%, enabling creative tool use in unseen scenarios. Significance fosters ethical, self-improving robots for homes and healthcare. The third selected research paper is Adaptive Relative Pose Estimation Framework with Dual Noise Tuning for Safe Approaching Maneuvers by Candon et al. 2025. It is picked for its impact on robust navigation in space, exemplifying challenging environment adaptations. The objective is accurate pose estimation for tumbling satellites amid noise for safe debris removal. Methods involve CNN detection, fused with adaptive unscented Kalman filters for noise tuning. Findings reduce errors by 65%, handling outages and high tumble rates effectively. Significance enhances space sustainability and extends to drones or underwater bots. Future directions in robotics are charted based on these papers. Hybrid AI physics models are anticipated to strengthen sim-to-real transfers for broader applications. Standardized benchmarks for embodied ethics are needed to ensure privacy and trust in social robots. Interdisciplinary fusions like bio-AI are expected for resilient designs in extremes such as space or oceans. Challenges to address include reducing computational burdens and improving generalization in chaotic settings. Opportunities involve reinforcement learning with quantum computing for faster training and multimodal sensing for intuitive interactions. This synthesis was created using AI tools, including